All right, welcome. Today, we're diving into one of the biggest questions in economics, one that tries to nail down the most slippery concept there is: the future. We're going to explore the super clever and sometimes, yeah, pretty mind-bending theories economists use to actually put a price on uncertainty itself. So, let's get right into it.
I mean, just think about it for a second, right? Every single day, we trade things like futures contracts, insurance policies, stock options. But what are you really buying? It's not a thing, it's a promise. It's a possibility. It's a bet on a reality that just hasn't happened yet. So, how in the world do you build a logical, mathematical market for pure potential? Well, that's the puzzle we're going to try and solve today.
Okay, so here's the game plan. We'll start with the basic idea of an economy in perfect balance, and then we're going to introduce this brilliant way to trade on what-ifs. Then we'll see how that idea got sharpened up into something way more practical. After that, we'll get into the really cool part, how prices themselves can act like information superhighways. And we're going to finish with a totally fascinating paradox where the whole system kind of predicts its own breakdown. All right, first things first. Our story really begins with this huge concept called general equilibrium. Now, just think of it as this beautiful, theoretical world where an entire economy, all the buyers, all the sellers, all the products, hits this perfect state of balance. Supply equals demand for everything, all at the same time. It's kind of the gold standard for economic models. Yeah, but here's the thing. There's a massive problem. The real world isn't neat and tidy. It's messy, it's chaotic, it's uncertain. Tomorrow it could rain, or maybe there's a drought, a company could hit it big, or it could go bust. How on earth were economists supposed to cram all the infinite what-ifs of the future into these perfectly clean, balanced models of theirs? So what was the big idea? Well, the first major breakthrough came from this really, really clever concept that completely redefines what a good can even be. It's called the theory of contingent commodities. See, a contingent commodity isn't just, a ton of wheat. No, it's a ton of wheat if it rains, or a ton of wheat if there's a drought. You're not trading the actual wheat anymore. You're trading a promise to deliver that wheat. But, and this is the key, only if a very specific future happens. It's all about that if. Let me give you a super simple example. Imagine a farmer. They can lock in their income today by selling promises for both possible futures. A company that needs wheat during a drought can buy the wheat if drought contract, and maybe a different company buys that wheat if rain one. The farmer gets paid today no matter what happens. Boom, the farmer's covered and the risk just got moved to someone else. It's a market for possibilities. So here's what's absolutely key here. All the decisions, all the price setting, it all happens now, ex ante, before anyone has a clue what's going to happen. You pay a definite price today for a maybe delivery tomorrow. And this is a biggie. For this clean version of the model to work, it has to assume that everyone is working with the exact same information. Okay, so this contingent commodity idea, it's genius in theory. But in practice, oh boy, it creates a huge headache. And that led to a solution that's just so much more elegant and streamlined. I mean, just try to imagine it. You wouldn't just have markets for wheat. You'd need a market for apples if it rains, and oranges if it rains, and apples if there's a recession, and oranges if there's a recession. You'd have a bazillion different markets. It's a total mess. Completely unworkable in the real world. So what's the fix? Well, instead of trading every single one of those contingent goods, you just trade a simple, pure financial asset. An Arrow security is basically like a hyper-specific lottery ticket. It pays out exactly $1, but only if one very specific thing happens. For instance, a security that pays you $1 if it rains and pays you $0 if it doesn't. And this is the truly elegant part. By creating these simple $1 payout markets, one for every possible future, you can perfectly recreate the outcome of that impossibly complex contingent commodities model. You get the exact same result, the same risk sharing, the same economic balance, but with a system that's so much cleaner. Okay, don't let the math on this slide scare you, because the idea is actually pretty straightforward. On the left, with the original model, you have this one giant complicated equation you have to solve all at once. But look at the right. With Arrow Securities, you break the problem down into simple steps. First, you use your money today to buy these lottery tickets for future alpha and future beta. Then, later, you just use the dollar you got from the winning ticket to buy what you need. And when you put those simple steps together, you end up in the exact same spot as the complicated model. It's two different roads that lead to the exact same place. Okay, hold on, because this is where things get really cool. So far, we've been assuming that everybody knows the same stuff. But what happens when that's not true? What happens when somebody in the market knows something that you don't?
So let's imagine a new scenario. We've got two kinds of people. You have the insider, who somehow knows for sure what's going to happen, if it's going to be state alpha or state beta. And then you have the outsider, who's just making their best guess. The insider has the cheat codes, while the outsider is kind of playing blind.
Now, you'd think the insider has this massive, unbeatable edge, right? But here's the thing about markets. Every move they make leaves a footprint, and that footprint is the price. When they start buying and selling based on what they know, they push the market price around. And if you're a smart outsider, you can learn to read those price movements like a secret signal. So, check this out. Because the insider acts differently depending on their secret, their actions push the final market price to a different level for each possible future. So in this example, if the true state is alpha, the market price for goods settles at 1/3. But if the true state is beta, it settles at 2/3. The key thing? The prices are different. So, now it's your turn. Put yourself in the outsider's shoes. You started out knowing nothing, but then you look up at the big board and you see the price is 1/3. What have you just learned for sure, with 100% certainty? You know the true state of the world is alpha. The secret is out. The price itself told you everything you needed to know. This is called a revealing rational expectations equilibrium. But, and this is the best part, this incredibly powerful theory of information and prices can actually tie itself in knots. It can lead to a complete logical paradox. It's the point where the model gets so smart, it actually proves that it can't work. Okay, let's try to break this down because it's a bit of a brain bender. First, let's just assume the price tells you nothing. The uninformed person believes the price will be the same no matter what. So, based on that belief, they make their trades. But when you actually run the numbers on how everyone behaves, the model spits out two completely different prices. Whoops, that's a direct contradiction of what we assumed, so that can't be right. All right, scratch that. Let's try the opposite assumption. Let's assume the price will reveal the secret. Now the outsider is savvy. They know they're going to learn the truth just by watching the market, so they change how they trade. But when you run the numbers with this new behavior, the model spits out the exact same price for both states, which means the price doesn't reveal anything after all. You see the problem? We've hit another dead end, a total contradiction. So we're stuck in this perfect, inescapable loop. If you assume the price reveals the secret, the math says it can't. If you assume it doesn't reveal the secret, the math says it must. In this very specific scenario, the model is so powerful it literally predicts a situation where it cannot exist. There is no stable price, no equilibrium that can logically happen. And that, right there, is the whole journey. We started with a simple, certain world, figured out how to handle an uncertain future with contingent commodities, made it practical with Eros securities, and then saw how prices could magically reveal hidden information, right up to the point where that same logic creates an unsolvable paradox. It's really a stunning intellectual achievement. And look, this isn't just some academic thought experiment. These ideas are the foundations of our entire financial system, which kind of leaves us with this final big question to think about. If these models show that market prices can encode the secret knowledge of insiders, what information, what secrets about our future are being broadcast by the market prices we see every single day? Something to think about. Thanks for tuning in.